Thank you, Nick. Machine learning, it's a big buzzword in the industry right now, and it may seem like magic to those outside our field. But those in this room know that we can use it to take historical data, figure out correlations between inputs and outputs, and use crazy fun math to be able to make future predictions. So that's what I have tried to do today. I was fortunate enough to get a headset, this headset that I'm wearing right now. And I am attempting to do something very, very fun, which is perform lie detection. Now, a little bit about me. I do work for Microsoft, but I'm not on the Azure Machine Learning team. I've collaborated with them a little bit since starting this work, but I am not on that team that builds it. And I do have a master's degree in machine learning, but my husband has a PhD, and a lot of my friends have a PhD. So I am like the Howard Wolowitz of my group of friends, if any of you guys watch The Big Bang Theory with just a master's. So you guys can all make fun of me too. I've been really excited about this work, and I'm super excited to share it with you guys today. So let me get started. This headset was not made by Microsoft. This is made by a company called Emotiv. I first learned about it in maybe 5 years ago in 2010 when the founder, Tan Lee, actually did an amazing TED Talk on the power of this device. And she was the founder of Emotiv. Yay for a woman-founded company. And woohoo! And it is just an incredible device. And ever since I saw that TED Talk 5 years ago, I have just coveted it so badly. I wanted one. And I finally got a chance to get one when I promised my boss, I'll do something cool with machine learning and EEG, and it'll be so cool. So that's how this project was kind of born, is me really wanting this headset, and then let's see what kind of cool things I could do with it. And I had all kinds of ideas. I have small children, so I was thinking put it on them and see if I can go all baby whisperer and figure out, when they're crying, could I figure out between, I'm crying because I'm hungry, or I need my diaper changed, or, there's really only like 4 things that bother them when they're really tiny. But due to Microsoft procurement policies, it took, I ordered it in December, and it didn't come until like May. And by that time, the kid was just too advanced for that to work. So I moved on to my second project. And that project was, I took the headset. Oh, that's bad. That's really bad. Let me just make sure that this is plugged in. We're all good. We're all good. We got this. Got unplugged with this. Woohoo! Thank you, Windows, for giving me that very informative message. What a lifesaver. All right. So what I decided to do after Baby Whisperer didn't work out is I took this headset and I put it on my husband. And I asked him a series of questions. And first I had him tell me the truth to those questions. And then I asked him more questions, and that time I had him lie to me. And I was recording his EEG while he was doing that. And then I took that data, fed it into Azure Machine Learning to attempt to build a classifier that could classify whether something was truth or a lie. So let me show you how I went about doing that. But first, let's take a step back. What is EEG? Some people, I know when they get started, are like, okay, can you just kind of clarify that? So to clarify that, let's of course turn to the source of all knowledge, which, as we all know, is Wikipedia, right? So according to Wikipedia, EEG is essentially, it's your brain waves. It's the electrochemical signals that are moving, and it's a very non-invasive way you can get to it. Like just, what this headset actually has saline solution, so I actually took contact solution, the same contact solution I use for my contact lenses, and you put it on each of the little felt pads. This particular one has 14 different channels, and so I wet them, and that helps conduct well, and then it can just measure, like, essentially the activity of your brain. And I do want to call out, hopefully no one in this room needs to hear this, but it is not mind reading. It's just a fun title, Fun with Mind Reading. It's not actually mind reading. So what I can do with this data is I can't tell what you're thinking, but I can create mappings between EEG signals and then some physical action, either in the virtual world or the real world, and I'll show you that in a second. And I can find patterns in the data and then be able to make predictions, like the lie detection, based on what I've learned. All right, so let me just show you a quick demo of just the power of this headset and some of the things that you can do with EEG. I'm going to jump over here, and this is a piece of software that comes with the headset. It's made by Emotiv, so I didn't write this. And this kind of shows off some of the things that it can do. So right now you can see everything is green. That means that all of the sensors are on my head, situated well and reading signals well. And I actually do have some brain activity, woohoo, even with a master's degree. So what the first thing you can do is there is this expressive suite. And as I kind of do my nervous twitches here and smile and blink and raise my eyebrows and lower my eyebrows. And here, let me see, look left. Or I'm sorry, I'm looking right. Look left. Is it doing it? I can't tell because I'm looking left. It is? Nice. Okay, cool. All right, so you can see what this tells us is that EEG, your facial expressions actually are effective in your EEG. So as your face moves in facial expressions can affect those waves. So that means that this data is extremely noisy, right? If just even facial movements are being picked up. It also means that you could potentially pick up things like nervous tics or twitches when somebody's lying. So that's kind of cool as well. So that's just a little something, and you can actually tune this to do even better too. This is just kind of the generic thing right now. But I'm going to skip the active suite, and I want to show you one more thing. So this was one of the things that really got me excited about this headset. Oh, and by the way, there is a developer SDK for this, and it does recognize those expressions that you saw. So you can build cool things like someone built a wheelchair for a paraplegic. So imagine being paralyzed from the neck down, and if they had a motorized wheelchair, and you could blink left to turn the wheelchair left, and blink right to turn the wheelchair right, and smile to move forward, that sort of thing. So it was a really cool application. Like, I love the ones, because there's of course all kinds of applications in like gaming and stuff like that, and just even monitoring like how flatline it is, how bored someone gets, because that's essentially what this active suite does. In the gaming world, have it just kind of flatline, and then you see someone getting bored, and you could dynamically, make another zombie come out, or something like that. So there's kind of a neat applications in real-time gaming and other things as well. But let me show you what this can do. So what I'm going to do right now is just train something and be able to move that box with my mind. So what I'm going to do first is actually train just based on neutral brain activity. So that it'll take 8 seconds. I am just going to think about nothing in particular. I'm going to relax my face. I'm probably going to close my eyes. And then it can see this is what my brain is like in a neutral state. All right? Don't make me laugh. Here we go. Okay, so we're good. We accept that, so now it has a state of neutral, and now there's several actions you can visualize. So pushing the cube, pulling the cube, turning it, rotating it, all kinds of things like that. So I'm going to actually choose pull right here, and then I'm going to train on that. So what I'm going to do is for 8 seconds straight, I'm going to visualize pulling that cube towards me with my mind, and it's going to be recording the EEG that's happening as that works. So 8 seconds again, and here we go. Okay. And now once I accept this, the cube will be live. And so I am going to attempt then to actually repeat the motion or my thought process of pull and try to make it pull towards me. So here we go after it updates. All right. I know, right? How cool is that? Let me do it again. I totally feel like Jean Grey right now. Isn't that cool? So awesome. So what I was doing there was thinking something. It actually works better. Like, I've been messing around with this for a while. It actually works better if you think because when I first started using it, I wanted to keep repeating like pull, 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 pull in my mind, and it actually works a lot better if you do one long pull like through the whole 8 seconds. But it's just amazing things. And so you can see that's just simply mapping, a graphics, whatever, making something pull to EEG. So very, very simple. That's not even machine learning. It's basically pattern matching, right? So, but really, really cool applications that you can see that kind of light up with this device. So now that we've all seen how absolutely cool this is, let's talk about my pet project. So Lie detection. So I had kind of heard the research that when you're telling the truth, it actually activates like the recall memories or the recall portions of your brain where it's pulling stuff out of memory and essentially doing recall. And when you're lying, it actually activates like the creative centers in your brain. So I started to think, because you had to like make up a story, you know? And so I was wondering, okay, if that's true, could I be able to tell the difference in EEG? Like, would I be able to tell the difference between whether someone was telling the truth or lying? And traditional methods tend to focus on things like the skin response, like how sweaty your palms get, heart rate, things like that. And so critics say that that actually isn't very effective. It measures how emotional you are, how high your emotions are versus actual, guilt. So that's what I decided to do is, okay, let me just try that out. Let me see if I can figure out if someone is lying or telling the truth based on EEG. So this was my experiment procedure. I took my poor sainted husband, sat him down in a chair. I did make him close his eyes and like relax his face. The reason was I wanted to eliminate any kind of facial rubbing, and you saw how in that demo how facial movements actually affect the data. So I wanted to kind of minimize it as much as possible. So I'm like, don't scratch your face or move around a lot or something. Just kind of relax and let's see if we can isolate the variables as best possible. And then I ran a tool called Emotiv Test Bench. I can pull that open for you in just a second. And then I asked each question out loud. And on the first run of the data, I actually, as he was finishing answering the question, I'd put a marker in the data. And essentially that annotated it with, here's where he was answering the question, so that I could pull out that time slice of, when his brain was doing that processing. And then I asked these 8 questions. The answer, some of these, the correct answer is yes. Some of these, the correct answer is no. I do not actually have 5 children, in case you're wondering. That one is no. And so he answered these questions multiple times, and he answered each one yes or no, and I recorded that. And I did run the data for asking truth and then asking lies, and I recorded those separately. And let me just show you Test Bench real quick. So this is the tool that I used to annotate. It's another neat thing, and it actually shows okay, so I'm trying to do something to get my brain make them go a little crazy. So you can see like that kind of response that's there. And so so there's a little waveform for each of these 14 channels that are touching my scalp. So you can actually isolate what's going on in the different brain centers. And then this is the marker where I can manually send a marker. So I would hit send like when the question was asked. And then on the second data run, I actually made it even more effective. I sent one marker at the beginning of asking the question, and then another marker after they answered. So to pull out all of that. And the reason was I was worried about anticipation. Like before I was putting the marker at the end of me asking the question, but I'm worried about that they can anticipate, like, because the question, were you born in 1978? Essentially, when he gets to born, he probably knows what the question is, so his processing might start earlier. So there's a whole bunch of other things I've just been thinking through, but I think I can pull it out more effectively the second way. But open to feedback if you guys want to talk about that later. All right, so that's Test Bench, and that's kind of how I did that. And then Test Bench actually dumps that to a proprietary format that you can then convert to CSV. So then I took the CSV and uploaded it into Windows Azure. And here, this is my poor sainted husband. You can see the headset. I threw a graphic in there just because you can see the headset on him a little easier than you can see it on me since I have more hair. So that is my giving me a look. No, Jennifer, I don't have an Ashley Madison account. Can I go watch TV now? Okay, we're very happy, really. The other thing that it does capture in that CSV is the sensor quality. So you saw when I was showing it to you earlier that it was all green. When I first started using the headset, like when you first unwrap them, like the sensor pads are really, really just really tight and dense, and you need to add just a ton of saline solution for them to be effective. And then the more I've used it, the pads kind of wear down and get a little softer, and then they actually conduct a lot better. So now I have no problem getting them to go all green, but I threw in some screenshots of what they kind of looked like earlier. But there's a numeric value assigned to the sensor quality for each one of those 14 sensors, and so that's really effective for your data cleaning process. So when I do go through and do data cleaning, I can throw out some data if it turns out there's the sensor quality just isn't up to par. One piece of research I wanted to bring up too, I did do a little exploration after we got to the point of EEG and lie detection. Has anyone looked at this before? Because it seems like somebody should have already looked at this. And I did find some research that I thought was kind of interesting. It's a little different than mine in that it doesn't require sitting and asking someone yes or no questions, but it has to do with recognition. And you know that feeling when you walk by, there's a face you recognize or something, and you walk by someone and you just get that little jolt of, hey, I know them from somewhere, and it's instinctive, right? You can't really control it. And so what I guess the CIA and FBI and stuff have experimented with is actually using that to help with lie detection, because EEG can pick up that. So the way it works is you don't ask the subject questions, you just sit them down, put the headset on them, and you show them images, pictures. And then if there are pictures that only the perpetrator of the crime would recognize, like a picture of the crime scene maybe, or the murder weapon or whatever, in those situations it actually causes this little dip, which they call the P300 because it happens approximately 300 milliseconds after the stimuli. So there's a neat kind of little dip between like 300 to 500 milliseconds that can occur. And so that shows recognition. And when, only something that only the perpetrator of a crime would know and they have that recognition, then they found that that's effective. So it's a little different than my work, but I thought it was interesting and related because it also gave me a sense of just the time frames that we're dealing with, like millisecond response times, that it's in the kind of hundreds of milliseconds that this is happening. All right, the last thing I wanted to call out in here is just the sensor positions. So when you open up the data, like the CSV that gets dumped here, there's columns for each of these 14 nodes, channels on my head, and I just have the reference in there of which one correlates to which center, which area on my brain. So for example, like right here is T7, and so you can see that in the spreadsheet and see, okay, is this doing something more, more so than some of the other ones? All right, so that's kind of my project. We looked at the headset, we looked at my project, what I was trying to do with it. Now, really quick about Azure Machine Learning. This was something I wanted to try. Again, like I think many people here, I have experience with machine learning. But the thing that was really cool about Azure ML is that you can very quickly, and it's almost like rapid application development for machine learning experts, because there's a whole lot of algorithms that are available. They are kind of like just using Python libraries and such. And so you can just kind of pull in and try a lot of different ones very quickly and easily. So I thought that was kind of cool. There's 25 different machine learning algorithms available in Azure ML right now. The majority of them are classification and regression algorithms. They do have a k-means clustering algorithm as well, and a couple of algorithms for anomaly detection, meaning in situations like credit card fraud detection, when you have a lot of data, here are good transactions that we are kind of known good transactions, and you don't have a lot of kind of the negative case, you don't have a ton of examples of known fraud, it can be hard to train a classifier effectively. So you can use anomaly detection to basically train on here's the range of normal, and then things outside of that range will get flagged. And there's modules for importing data and cleaning data, for annotating it with metadata, and then you can create these experiments, train and test your models using various means, and then publish them as a web service, and then you can expose that web service over a REST endpoint, and then just make calls. And it actually generates sample code for you, like when you kind of hit go and create the experiment. It'll generate sample code for you in C#, Python, and R. So you can use any of those languages. And there's the ability to insert little scripts in there as well, Python scripts as well as R scripts, right inside of Azure Machine Learning too. So this is kind of the template of what supervised learning might look like. You would import some kind of a data set, and there's lots of different ways to do that. You can do, so I had a CSV here, and I just uploaded a CSV. You can also, there's stuff to various things for reading data over the internet. So there's a generic OData feed provider. There's just pulling stuff over HTTP. There's ways to access Azure, like Azure Table Storage, SQL Azure, Hadoop, using a Hive query against a Hadoop cluster. So a lot of different things you can do there. And then there's a lot of different data cleaning modules, removing missing rows, things like that, annotating stuff with metadata, making strings into categories and things like that. And then you can split your data. And there is support for doing things like a stratified split as well. So if I have, like the case of lie detection where maybe I have a very small number of things and I want to make sure that those kind of go equally or get split in a nice proportion into my training test and test set, that can be effective as well. So then we do our split, and then you can apply some algorithm here. And then we train our data with, roughly 70% or whatever you'd like. And then we can hold back some of that data to be able to test our model, see how well it performs. And then you can kind of repeat that process with a different algorithm, like over here, for example, and then be able to compare two models against each other. And that's kind of interesting as well, just when you're kind of rapidly iterating on, hey, what's working best? And I'll show you what that looks like in a second. So let me jump up to the algorithm part then, for choosing an algorithm. So there's a really neat cheat sheet that the Azure Machine Learning team put out. So if you're newer to machine learning, or if you just want like a handy dandy reference, this is actually a really cool flow chart, I think. What it does is, this is the first version that was out, and the one that's up there this one actually isn't, I don't think, publicly available anymore, but I have a copy of it on my hard drive if any of you guys want it. And then I'll show you the one that is publicly available too. But this one is kind of written out as a flow chart where essentially you kind of start here, and like with my lie detection, for example, do I want to predict future data points, or did I want to, discover patterns in data, and I want to predict future data points, so I would go here. Am I predicting categories versus values? And I'm doing categories because it's a discrete truth or lie, versus like predict the price of a house based on something would be values and use regression. So I would come up here to these categories, and then it's asking two categories or more than two. We have different things for multi-class classification, and I only have two, truth and lie. So I would go here, and then if one of the categories is rare, you can kind of head into the anomaly detection section, but I had a roughly 50-50 split. So I'd go here, and then it asks a lot of great questions around what does your data look like? Do you have less than 100,000 data points or greater than 100 features? Do you prefer speed or accuracy? Do you want it to be easily explainable class boundaries? Is it, you want to update it with fresh data, because things like Bayesian algorithms update well, and things like neural nets, you have to rerun all of the data. So all these kind of considerations for what algorithm would work the best for your needs. So it's kind of I think a nice reference for just machine learning folks in general. So this was the original version. It's very flowcharty in this version, and this is the version that's publicly available now. It's more declarative in nature almost, where you kind of do your split, figure out that I want to go to two-class classification, and then basically this one is like, here's what each one is good at in a more declarative sense. Like this one has fast training and it's a linear model. This one, is good for large memory footprints, etc. So very, very cool stuff. And then if you would like to download this yourself, I did throw a link in there. It's aka.ms/Azure Machine Learning cheat sheet. That is the link where you can download it right now. And then feel free to ping me if you want the older version too, and I'll send it to you. And then I also wrote a quick blog post on like getting started with Azure Machine Learning that I threw up there for reference as well, if anybody needs it. All right, so now let me jump into Azure Machine Learning and show you what I did with my lie detection experiment. Okay, so I uploaded both of I told you I did those CSVs. Did I show you the CSVs? So here's what the data looks like that came out of Test Bench. And you can see here are the 14 channels of data right here. So I just have all these data values. It also has a gyroscope in here. So it keeps track of those motions as well. This marker column is where those ones would hit when I was annotating where I was asking the question. So I can use that to pull it out. There is the sampling rate. I forgot to mention the sampling rate. The sampling rate is 128 readings per second. So that's how fast it was taking. So that's roughly every 8 milliseconds it would take another reading. And then we have the context quality for each of these. Oh, there's a timestamp, a milliseconds and seconds timestamp, and then the context quality for each sensor too. So you can see this one is all green because these are all reading 4 right now. And then I annotated this as well with whether it was is truth or is lie to have a labeled column. So that's what my data looked like, and I imported both one of the truth runs and one of the lie runs and just merged them together with this add rows. And then to be able to do these things, all you need to do, since I'm not creating this for you live, is you just drag and drop these various modules and wire them up together. So it's really simple and easy to do. And again, I love it for like almost rapid application development of I want to try out some things, and it makes it super easy. So here we go. I added the rows, then I used a metadata editor to define what my label field was. So the is truth I wanted to set as the label or the output, the thing I wanted it to predict. Everything else by default will be listed as a feature. So if there's stuff you don't want to be included as a feature into your algorithm, there's a clear feature field in here too that you can utilize. Like if there's like an ID column where it's just a randomly assigned ID, you can clear feature on that so it won't use that as an input into your algorithm. And then I did a project columns, and what the project columns does is I actually was eliminating some of my columns that weren't relevant. I threw out some of the data that I didn't think was relevant. And then I did a split, and this was a 70-30 split here. And for one algorithm I tried was a two-class logistic regression, and then the second one I tried was a decision jungle. And so I trained the model on both of those. And actually for the linear algorithms, if you right-click on the output and hit visualize, it actually shows you, so these are the kind of initial parameters, and you can tweak those for each of the algorithms. If you select the module, it gives you all the initial parameters and stuff that you might want to play with, so you can mess with those a little bit. So you can see what I have there, and it actually gives you the output of here's the weights that it came out with. So in this case, you can see the P8 sensor actually had a very strong negative correlation to whether it was the truth. So really, really interesting to see, where those effects actually happen. And right now, that's only available with the linear algorithms, but I think they're going to add them to the decision jungles and such as well, too. All right, so then I can evaluate these two models and compare them against each other at the bottom. So again, if I right-click after I run it and hit visualize, then you can see right here a nice lift chart of what's going on. So essentially, the way to interpret this, so this diagonal line across the middle, that's essentially 50-50 random chance, right? And so what you can see here is that this one did not perform very well. It did okay, but not the greatest. And then the decision jungle was actually very effective. And so if I select that and move down a bit, you can see the various data that's provided. It gives you the number of true positives and true negatives when running that test set against the trained model, and false positives and false negatives. So of course you want these numbers to be high and these to be low. And then it gives you accuracy numbers, recall, precision, all kinds of stuff like that. The F1 score. So it's it's been very, very effective in how well it works. So that's been very fun. Let me jump back here real quick and show you how am I doing on time? 5 minutes? 5 minutes? Okay, cool. So let me mention a few things that are kind of shortcomings. Being a former good little grad student, it's always like, okay, what is wrong with this? What's bad about this? The first thing that I was worried about was, hey, the EEG data is polling, right? It's doing 128 readings per second. Is that good enough? And I actually think that's okay. Like after I did some research and I was looking at like that P300 work, you saw that those reactions were happening, 300 to 500 millisecond range. And so since it's giving me readings every, 8 milliseconds, that seems like it would do a fairly decent job. So I'm kind of okay with that. Initially, on the very first data run I did, all of the sensors weren't sending data, but this is now okay. I've rerun a couple more data sets, and I'm now I'm pretty good at getting the set to go all green all the time. Right now, the data that I was showing you just then was a single user data. So it's basically a lie detector for my husband, which is a very good thing to have. But it'd be cool to make it more generic. So to deal with that, I'm actually collecting data from a lot of people. And if any of you guys want to give me your data while I'm here during a break, I wouldn't be opposed to that. It would be very nice of you. So grab me if you want to. Then I can, I want to take the data and just see if I can generically make something that works across everyone well. And I'm also in the second data run recording like a neutral brain state as well. So that way I can do things like take the delta between, what is it when they're truth lying and the neutral brain state. So I think that will be effective too. And then the last thing, and this is the one, so I'm working on the bullet 3. I'm okay with that. So the one thing that I think is probably the most frustrating is the accuracy of the markers. So really being able to pinpoint, since we're dealing with a matter of milliseconds here, really trying to nail down exactly where the processing is happening and they're really doing truth or a lie. And so pulling that out of the noisy EEG data I think will be tough, and just making sure I'm really getting, how close can I narrow in on when they're actually thinking about their response and deciding what to do. And so right now, the accuracy is, I think it's actually a little bit improved, but I'm doing, like, when I start asking the question to when they respond, and then just focusing on that a little more. All right, so the next steps, I have the effort underway to kind of genericize it to see how well I can make it work for anyone, develop a lie detector that would work for everyone. I'm doing different experimentation with feature extraction, so figuring out what are the most relevant features, what are the most interesting features here. Since it's time series data, I'm trying to do some fun math with taking the waveform essentially over time, like each of the 14 channels, and kind of expanding that out into one really long feature, which is interesting stuff. And then I'm also doing some stuff of comparing the data against a neutral brain state, because maybe my peaks or whatever, when I get excited, like peak to, say, 12, which is not right, but just imagine, play with me. And somebody else peaks to like 6, you know, they just don't get as as I do. So in that case, you can do something like that, where you could use things like that to even that out. And then I'm experimenting with different algorithms. As I try these different feature sets and stuff like that, I use different algorithms in there, depending on like how big my data set is and things like that. So it's really, really interesting work, and I hope to be publishing more on my blog and such over the next month or so. Oh, I did want to mention Microsoft Virtual Academy, as well as Channel 9, have a lot of great online free stuff from Microsoft, so it's awesome. Feel free to check that out if you'd like. All right. Thank you guys so much.